A very good morning, madam. My name is M. Varshasri. My roll number is 234G1A33I1. I'm studying in first BTech second semester from the Computer Science and Engineering, Artificial Intelligence and Machine Learning branch. And today I'm here to give a PowerPoint presentation for the subject Engineering Physics, and subject code is 23PHY01 for the topic Extrinsic Semiconductors, that is N-type semiconductor. The introduction to the N-type semiconductor. N-type semiconductor is a type of the extrinsic semiconductor doped with the impurities that introduce free electrons into the crystal lattice. The impurity atoms in N-type semiconductors are typically group 5 elements like the phosphorus or the arsenic. The excess electrons introduced by the dopant atoms makes the N-type semiconductors conductive. The doping process in the N-type semiconductors. During the doping process, the group 5 elements replace some of the host elements in the semiconductor crystal structure. The dopant atoms have one more valence electron compared to the host atoms by creating an excess of free electrons in the crystal. This excess of free electrons is responsible for the N-type semiconductor's conductivity. The electron carrier concentration in the N-type semiconductor. In N-type semiconductors, the majority charge carriers are the electrons, which are introduced by the dopant atoms. The concentration of the electrons in the N-type semiconductors is typically higher than the concentration of holes. The electrons in the N-type semiconductors move in response to an applied electric field by contributing to the conductivity of the material. The energy band diagram of the N-type semiconductor. The energy band diagram of an N-type semiconductor shows a conduction band with a higher energy level than the valency band. The Fermi level in the N-type semiconductor lies closer to the conduction band, indicating that the abundance of the free electrons. The band gap between the valence bands and the conduction bands determines the semiconductor's electrical properties. The carrier mobility in the N-type semiconductor. The carrier mobility in N-type semiconductors refers to the ability of the electrons to move through the crystal lattice in response to an applied electric field. The mobility of electrons in N-type semiconductors is influenced by factors such as the scattering mechanisms and the dopant concentration. The higher carrier mobility contributes to the better conductivity and the faster electronic device performance. The N-type semiconductor application. N-type semiconductors are commonly used in the electronic devices such as the diodes, transistors, and the integrated circuits. The abundance of the free electrons in the N-type semiconductors allows for the efficient electron flow in the electronic circuits. N-type semiconductors play a very crucial role in the modern electronics and semiconductor technology. The temperature dependence of the N-type semiconductor. The conductivity of N-type semiconductors is the temperature dependent, increasing with the temperature due to more free electrons being thermally excited. However, excessive temperature can lead to the carrier freeze out and reduce the conductivity in N-type semiconductors. Understanding the temperature dependence of N-type semiconductors is essential for the device performance and the reliability. The N-type semiconductors fabrication. N-type semiconductors are fabricated through processes such as epitaxial growth, ion implantation, and the diffusion of dopant atoms into the crystal lattice. Precise control of dopant concentration and the distribution is critical in N-type semiconductor fabrication to achieve the desired electrical properties. Advanced fabrication techniques ensure the consistency and quality of N-type semiconductor materials for the electronic applications. The future trends in the N-type semiconductor technology. Ongoing research in N-type semiconductor technology focuses on enhancing the carrier mobility, reducing the power consumption, and improving the device performance. Emerging technologies such as the quantum dots and nanowires are exploring novel approaches to the N-type semiconductors design and the fabrication. The continuous evolution of N-type semiconductor technology drives innovation in electronic devices and semiconductor history and industry. The conclusion: N-type semiconductors play a very vital role in the modern technologies and electronics by providing a conductive material with an abundant free electrons. Understanding the properties in the behavior of an N-type semiconductors is essential for the designing and fabricating the high performance electronic devices. The versatility and the applicability of the N-type semiconductors make them indispensable in semiconductor technology and the future technological advancements. In an N-type semiconductor, pentavalent impurities are used for the doping. The impurity is called the donor impurities. Thank you for giving me this opportunity.